What is going on, everybody? Welcome back to my YouTube channel, Richard on Data. And if this is your first time here, my name is Richard, and this is a channel where I help you break into data science and grow your skills in the field. So this is another video in my R tutorial series. In the last few videos I did over R, we covered using the Caret package to do machine learning. It was a 4-part series, and I highly recommend watching that series before watching this one. Well, Caret is not the only package that you can use in R for machine learning purposes. There's this whole framework of packages known as tidymodels, and that's what we're going to cover in this series. Now, the reason I recommend watching my Caret videos first is because, at least at the time I'm recording this video, which is March of 2021, Caret is a little bit more mature. It has a lot more fully developed capabilities, and some of the packages in the tidymodels suite, they're at pretty early versions. That is, they're at versions like 0.1 or 0.2, whereas Caret, it's a lot more fully developed. I fully expect a lot of just future R development for machine learning to take place under the tidymodels ecosystem. So a year or two from now, tidymodels could be a much bigger thing than it is now. But just for now, for the most part, I'm going to try to structure this tutorial to be as accessible as possible, but there are some instances where I'm going to point to this is covered in a little bit greater detail in the Caret videos. So before we get started, take a moment to smash the like button for the YouTube algorithm and subscribe to my channel if you haven't already. And then if you guys would be willing to support my channel, I will have links in the description of the video to things like my PayPal address, my Patreon account, and my crypto wallet addresses. And then, as usual, this script will be available on my GitHub repo, which is also in the description of the video. Now, without further ado, let's get started. Alright, so the first thing that you're going to notice is I'm calling more packages here than I usually do. Now, the first thing that you have to understand about tidymodels is that it's an ecosystem of packages. So kind of like with the tidyverse, with tidyverse, you have packages like dplyr for data manipulation, ggplot2 for visualization. All those packages are part of the tidyverse, and when I call the tidyverse, all of those packages are automatically loaded in. That's generally the case with tidymodels too. Now, there are some more new packages like themis or stacks, which you, for now, have to call separately. But just think of it very analogously to tidyverse, to where if you call the tidymodels package, many of your dependencies are going to come in. Now, if you've seen the Caret tutorial, you remember that I worked through a full example for the GermanCredit dataset. The only reason that I'm going to call the Caret package here is just to load in that GermanCredit data. Now, towards later in this video, you're going to see where some of these more individual machine learning packages like random forest or KKNN for k nearest neighbors are going to come into play. Now, there's a number of sources from which this tutorial draws influence and structure. Those will, as usual, be linked in the description. Those represent fantastic supplemental reading above and beyond this tutorial series. But the overall list of packages which make up tidymodels that we're going to make use of in this tutorial series are listed here. We're going to go through each of these individually in their own section, but you see that each of these packages serve a different purpose within the entire machine learning pipeline. So in a machine learning problem, you typically will have to start off by partitioning your data into testing and training. Functions from the rsample package are going to help us to do that. Now, rsample in and of itself does not have a ton of functions, but the functions from that package are going to help us with this task. So on and so forth for the recipes package. That's where we're going to do things like pre-processing our data before we train models, parsnip when we actually train the models, so on and so forth. Now, if you've seen the Caret tutorial, you know that I start with the GermanCredit dataset, and there's a little bit of just overall pre-processing that I want to do to that dataset up front. The dataset is a little bit cleaner than what you would typically expect from real-world data, so I just do some completely tangential stuff in order to do things like simulate some missing data. That and just turn these things into factors when that's clearly the appropriate data type for those variables. Then just call a summary of the data set up front to get a feel for what that looks like. So if you haven't seen the tutorial series on Caret, I'm just very briefly going to go over some things you need to be aware of with this data. First of all, the response variable here is class. This essentially indicates for every individual subject, do we expect them to be a good credit bet or a bad credit bet? You'll see it's got a 70-30 balance here. 700 out of 1,000 subjects are good credit bets. 300 out of 1,000 are bad. So we've got a classification problem. So we have a few continuous variables over here, but you have some of these factor variables like number existing credits where you have levels that simply don't show up a lot. Like 0.6% of subjects have 4 existing credits or more. So you have a little bit of variance imbalance there. But even going beyond that, you see some of these variables, like take telephone, yes or no here, foreign worker, yes or no, or 1 versus 0. But then you have these other variables here which are in dummy form, meaning every level of this housing variable here gets its own column. So rent, own, and for free are different levels of this housing variable. You'll see that 0.179 plus 0.713 plus 0.108, well, that all adds up to 1 because, again, they're just different levels of one variable. So you see that these factors are just coded in different ways, and we need these things to be consistent in order to have a robust machine learning classifier. Now, we're going to use various tidymodels functions in order to fix this up. But I will say the first thing that we're going to do just up front is collapse this variable number existing credits. So instead of having 4 levels, 1, 2, 3, and 4, because 3 and 4 occur with pretty low frequency, all we're going to do is collapse to 1 versus 2, 3, and 4 all get their own category. So I'm kind of doing that on a pretty arbitrary basis, but that's just how I'm choosing to tackle this problem. All right, so the very first package from tidymodels that we're going to make use of here is the rsample package. I already spoiled at the beginning of this video what it's going to be used for, but it's in order to split our data into training and testing sets. Yes, granted, there are other functions in rsample, and we're going to see an example of one of them later, but that's the number one thing that you're going to use this package for. Now, if you're unfamiliar with the broader machine learning framework, the reason we do this is we want to train our classifier on a training set, but then we want to evaluate the performance of that classifier on a testing set, which consists of data that classifier has not yet seen, okay? Now, if you've seen my Caret tutorial, this is going to look pretty similar to the create data partition function from Caret. What we're basically going to do is we create that initial split using this initial split function. So this p or prop argument here specifies what proportion of the data we want to use for training purposes. Anything from like 60 to 80% is pretty common here. I'm just going to use 70% of the data for training. The remaining 30% is for testing. And I want to do this splitting proportionally with respect to the class variable. Again, that's our response variable. We want that same 70-30 split that exists with that class variable to exist for the training set and for the testing set, okay? So all we do is create that initial split. Then we can use the training and testing functions to extract the training set and the testing set from that split object that we created. Okay, so let's just create a summary of the training set to make sure that we did this correctly. And we see that we have 700 rows to the training data. That's what we expect because 70% of our initial 1,000 subjects should be used for training. But then remember that our split for the class variable is also 70-30. If you look here, we have 490 out of 700, that's 70%. Are expected to have good credit, and 210 are in the bad class. So this passes every test so far. This is looking good. That about covers what you need to know for now from the rsample package. The next one we're going to go through is the recipes package. So most of the steps and functionality that goes into pre-processing a dataset to get it into an appropriate format for training a machine learning classifier, most of those steps are going to come from the recipes package. So some of the key steps that I like to use here are step KNN impute. That's going to impute missing data using the KNN algorithm, or K nearest neighbors. Step dummy, that's going to get all of our factor variables into a consistent format. So remember with our housing variable, where each level of that variable got its own column? Well, we want all the factor variables in our data to be in that format. For machine learning purposes anyway. So that's where step dummy is going to come in. Step NZV is going to get rid of variables with near zero variance. And then we have step range over here. That's basically for normalizing our variables so that the variables fall within a range from 0 to 1. Some algorithms, they get tripped up if you have variables with radically different ranges, neural networks being an example. That's not the case with all algorithms, but with enough of them, having variables with different ranges presents enough of a problem to where just getting in the habit of normalizing variables will tend to save you some headaches. Note that that's different from standardizing variables, which is from converting them to z-scores. So actually step normalize, if you use that function, that will help you standardize the variables. But what we typically refer to as normalizing, that is converting to a 0-1 scale, doesn't come from step normalize. It comes from the step range function. So that may be one thing that can trip you up or confuse you at first, but just as long as you get used to the syntax, you're good to go. Now, there are some super useful helper functions which are going to make our life easy here. So for instance, all predictors, that's pretty self-explanatory. We are going to start up front actually by defining a formula and what data set that we're using. So class is our response variable. We use this format or the syntax here to indicate that all the other variables in our data set are predictors. We're using the training set here. And so when we use all predictors, we're just telling this recipe here that we want to use the KNN algorithm for imputing missing data for all predictors. We're going to use this step dummy approach for all nominal variables or all of our factor variables, but not all of our outcomes. Because remember, our outcome variable here is also a factor variable. The class variable has 2 levels to it. But we don't want to use that dummy approach for our response variable. So a similar thing for the step NZV and for step range. For step range, we're going to specify minimum equals 0 and maximum equals 1. So think of this completely to like a recipe that you might use for making dinner. So you look at the steps to the recipe. You've got your step 1, step 2, step 3, step 4, or whatever. So you prepare that recipe. So you have all your ingredients up front and you know what order that you're going to do various things in. And then you basically conduct that recipe, right? It's kind of analogous here with our syntax here, where we start with this recipe object that we defined up here, a credit recipe. Then we prep that on the training set, and then we bake it. So it's a little bit weird because we have 2 functions for this, but we're just going to prepare all the steps and then apply them, and then we using this bake function. Once we do that, we're going to get these new data sets here for which all of these steps have been applied. Now, you just saw me do this for both the training set and the testing set. We applied all the exact same steps for the 2 different data sets. So that's a lot cleaner than doing something similar in Caret. One thing I will say compared to Caret that's not necessarily easy is recursive feature elimination. So you saw in the Caret tutorial, there's the RFE set of functions in order for eliminating variables that just are useless or not informative. That's not to say that they're near zero or actually have zero variance. They're just useless variables that don't help us perform better for training a machine learning algorithm. Now, that procedure is pretty straightforward and the functionality is all developed in Caret, but it's not developed yet in tidymodels, at least at the time that I'm recording this video. So Max Kuhn, and he was one of the biggest individuals who's worked on the tidymodels suite of packages, he's come up with a custom solution in order to do this, and I'm going to have it linked here, but it's not super clean or straightforward. Now, even in the Caret tutorial, I showed you how to do it, but I didn't necessarily do it. So if you want to learn how to do it, the link is going to be provided here in order to do it. The parsnip package is where the fun really starts to begin, and that's where for the first time we're going to start actually training and fitting our machine learning classifiers. So the first thing that we have to do is actually specify the models and how these things are actually coming about. And now the syntax for this gets a little bit weird, so I'm going to explain how all of this comes together. Now, for the most part, every individual method is going to have its own function. Now, I want to train a logistic regression as well as a random forest. So the logistic regression gets its own function, up here logistic reg. Random forest gets its own function, that's rand forest, okay? So you can either then, using the pipe function, pipe to set mode, or you can specify the mode just as an argument to this parent function here. But we need to also specify, is this a regression case or a classification case? This is a classification scenario because our outcome variable here is discrete. It's not continuous, so this is a classification problem. Then the next thing that we have to do is set the engine. Now, actually, if we move on to the random forest, what the engine is going to make a little bit more sense. So there are multiple different packages which can be used for random forest implementations. Random forest is an example of a package which can be used to create random forests. The ranger package is another package which can be used for random forests. And so if you use those different packages, you are probably going to end up with different results. And so that specification is going to come from this set engine function here. Now, if it looks like the syntax just gets like a little bit of looking stuff up, like, okay, if you want to try a different method, you have to look the syntax up. Here's a shortcut which is going to make your life a lot easier. If you go up here to add-ins, go down here to generate parsnip model specifications, give it a second here, and then over here, there's this UI which is going to pop up, which is going to basically help you write the specification code for you. So you're going to specify what type of model do you want. Is it classification or regression? Then over here is a list of all the different methods, okay? So for example, BAG-MARS, that would be an implementation of multivariate adaptive regression splines that comes from the Earth engine, or the Earth package. And so if you do this, there's no need to memorize all this stuff. So that can make your life significantly easier. So we can, in the next step, go on to actually fit these models that we've now specified. All that we need to do is specify the model object, the formula, and then the data set that we're using, that we're fitting these to the training data. Now we have our fit objects. We can go in and look at what the output looks like. For the logistic regression, it's pretty straightforward, typical logistic regression output. Pretty similar kind of thing for the random forest. Okay, so that's where I'm going to leave you. In the next video or videos here, we're going to move into actually evaluating the performance and seeing how we did on the testing set, and then going a little bit deeper into things like downsampling and upsampling as far as pre-processing the data to deal with class imbalance, and then going a little bit deeper into actually tuning our hyperparameters. So thanks for watching this video. If you enjoyed it, please consider sharing it. Smash the like button for the YouTube algorithm. And then I'll see you all in the not so distant future. Until then, Richard on data.